Today we're going to be learning about the compound interest formula. A equals P times the quantity 1 plus R divided by N raised to the N times T power. This formula has lots of variables that are defined on the left side of your screen. A is defined as the final amount in your account. P is equal to the principal value or the starting value in your account. R equals the rate. You must remember to change this to a decimal. N equals the number of times the interest is applied per time period. And T represents the number of time periods that have elapsed. There are several compound interest words that you need to become familiar with. They are as follows. Compounding annually means that the end value will equal 1. Compounding semi-annually means that the end value will equal 2, or interest will be paid twice a year. Quarterly means that interest will be paid 4 times a year. Monthly, interest will be paid 12 times a year. Weekly, interest will be paid 52 times a year. And daily, interest will be paid 365 times per year. Please pause the video if you need to take notes on this particular screen. Now open your packet to page 10 and we're going to go over example number 7 together. You put $350 in a savings account that earns 3% annual interest compounded yearly. You do not make any deposits or withdrawals. How much will your investment be worth in 4 years? Because the word problem contains the word compounded yearly, you're going to need to use the compound interest formula. We start off with the principal value, which is $350. Then we follow the formula and we replace the R value with 3%, which written as a decimal is 0.03. And then in the word problem, it says compounded yearly, which means 1 time per year. Therefore, the end value is going to be 1 in the denominator of this fraction, and it's also going to be 1 in the exponent portion of the equation. The last variable that we're going to need to replace is T, and T represents the time that has elapsed, which is 4 years. After substituting all the values into the right side of the equation, you can use your calculator or decimals to calculate or evaluate what this expression is going to equal. After inputting the information into decimals, I got 393.9280, which is approximately $393.93. Your investment will be worth $393.93 in 4 years. Example number 6. You buy a new computer for $2,100. The computer decreases by 50% annually. When will the computer have a value of $600? In this particular word problem, there's no mention of compounding. Therefore, we're going to use the exponential equation instead of the compound interest equation. The exponential equation is y equals a times b raised to the x power. The initial value is $2,100. Now we look to substitute the value of b. In the word problem, it states that the computer decreases by 50%, which indicates the b value should be a decay value, which is going to be 1 minus 50%. And when you change 50% to a decimal, it becomes 0.50. Because this word problem does not indicate a specific time, we're going to be solving for the time, which whenever we use the exponential equation, time is represented by x. Therefore, we're going to plug in the variable x. Now, in this particular equation, we have 2 unknown values, but we are given the value of the computer to be $600. Therefore, we can replace the y value with $600 equals 2,100 times the quantity 1 minus 0.50 raised to the x power. We're now going to use decimals to solve this equation. I've already typed the equation. 600 equals 2,100 times the quantity 1 minus 0.50 raised to the x power into decimals. And when I go to the graph and click on the x-axis, I'm looking for the x-intercept. As I click on the x-axis, it's a little difficult, but decimals will allow me to zoom in further and further to find out what the x-intercept is, which is my answer for the value of x. And we see that the value of x falls somewhere between 1.5 and 2. Because I haven't been able to figure out the exact answer, I'm going to change decimals up a little bit and change my equation into an algebraic expression. Therefore, I'm going to go up and delete the 600 equals. Leave my expression that was there. I just deleted the 600 equals, and I'm going to type y equals 600 in the next dialog box. When I do that, what that does is when I press the home key, it allows me to get closer and closer to what the graph looks like. So I'm going to zoom out. I'm going to zoom out until my y value gets closer to 600. Right now, my y value only goes up to 10. So I'm going to zoom out quite a bit more until my y value I can see close to 600. And now y equals 600 is the green horizontal line. So now what I'm going to do is I'm going to click where the green line and the blue graph intersects. And this gives me the point of intersection of the blue expression and the equation y equals 600. The point of intersection is the solution. Therefore, the solution, or the value of x, is 1.807 rounded to 3 decimal places when y equals 0. So my answer for x is approximately 1.8. The computer will have a value of $600 after approximately 1.8 years. This is the end of the examples found on page 10.